So you're probably asking yourself, Mr. Mac, why am I doing all this factoring? Why am I turning all these addition and subtraction problems into multiplication problems? Well, we're going to use what we see here, this vocabulary, the zero product property. Product of factors is zero if and only if one or more of the factors is zero. Meaning, if we have two unknowns, two things multiplying that equals zero, one of these, either this or this, one of those must be, one or both must be zero, be equal to zero. So this one has to have a zero, or this box has to have a zero in order for a product to equal zero. That's no other number. That's why we set it equal to zero. We always set our equations equal to zero. You saw that later on in chapter 7, but this is where it first gets introduced. So we have this problem, and it's already set equal to zero, and it's already factored. So we have two numbers that are multiplied. So the question really is, what value for y would make this box equal to zero? And the way we write that is we set that equal to zero. And then the other question is, what value for y would make this box equal to zero? Because one of those two boxes must be equal to zero, because that's the only way a product of two numbers equals zero. So we subtract 4. We say, oh, hey, when y equals -4, that would make this box equal to 0. And when y equals 5, that would make this box equal to 0. So if we look at this, so those are my two solutions. Those are my two solutions to make it equal to 0. Let's take a look. Let's look and see with our checking. We have our y equals, or y plus 4, y minus 5 equals 0. I think that was the starting problem. Yeah. So what do we get when y equals -4? So if y equals -4, let's plug that in. -4 plus 4 times the quantity -4 times minus 5. So here we get 0, here we get -9, and 0 times -9. So yeah, that's a solution. So this worked. This solution did work. It checked out. Let's try the other solution. Our other solution was when y equals 5. So if we plug in 5 for y, 5 plus 4, and 5 minus 5. So 5 plus 4 is 9. 5 minus 5 is 0. 9 times 0 is 0. So that also is a solution. So we see that when y equals -4 or y equals 5, that will be a solution. What if I picked some other number? Let's take, what if I checked y equals 3? It's not a solution, but what if we plugged in 3? We have y minus 4, I think it was y plus 4. Y plus 4, y minus 5 equals 0. So if we tried 3 plus 4, 3 minus 5, that's 7 times -2, that's -14. Notice that was not a solution. So that is not a solution. So no other numbers outside of -4 and 5 will work. So these first couple of problems, we're just going to take each box and find out what is the value for n to make that box equal to 0. So we set each binomial equal to 0, and then we solve for it. N equals -1, n equals -8. And so my solution set is going to be -8, -1. We're always going to put it in numerical order. And we can check if you want, but you don't really need, I mean, yes, you can, of course, you can always check. So this is an interesting one because, hey, look at this. This is actually a box, and this is my other box. So 10n equals 0. What value for n is equal to 0? And then here's our other one. n minus 2 equals 0. What value for n would make that box 0? So divide by 10, n equals 0. So that's one of the solutions. And then what value for n in that box would make it equal to 0? So when n is equal to 2, that would make this box equal to 0. So my two solutions are 0 and 2. Again, take 2x, set that equal to 0, x minus 10 equal to 0. Divide by 2, now let's solve. X equals 0, plus 10, x equals 10. So my solution sets, my two solutions are 0 and 10. And we see how much easier it is when it comes already pre-factored, that it's a product of two numbers that equals 0. So p minus 1 equals 0, p minus 7 equals 0, add 1, p equals 1, add 7, p equals 7. Solutions are 1 and 7. Now we have three numbers multiplying, or three unknown, three boxes multiplying to make 0. You can have 4, 5, still one of them has to be 0. That's the only way. So we're still going to set each box equal to 0. And then down here, n minus 3 equals 0. So divide by 2, n equals 0. That's one of the solutions. N equals 1. That's another solution. And n equals 3. That's my third solution. So 0, 1, and 3. We can have three solutions here. Yeah, three values that would be a solution to that polynomial. So again, x equals 0, 2x minus 1 equals 0, and 2x plus 1 equals 0. That's a solution that's already isolated. Let's add 1, divide by 2, x equals 1/2. Let's minus 1. Let's divide by 2, x equals negative 1/2. So my three solutions in numerical order is negative 1/2, 0, and 1/2. Back to the simple one, n equals 0, n minus 6 equals 0, add 6, n equals 6. That's already isolated. 0 and 6 are my solutions. We have 3x equals 0. We have 4x minus 1 equals 0. And we have x minus 2 equals 0. Divide by 3. X equals 0. Add 1. You get 4x equals 1. Divide by 4. X equals 1/4. Add 2. X equals 2. So numerical order is going to be 0, 1/4, and 2. Now, okay, so here we have, now we're going to go through our criteria again, because we have this polynomial that's being added and subtracted. So we got to factor. We got to turn it into a product. Turn into a product. So number one, remember my list of things? First one is actually going to be set equal to 0. So it is set equal to 0. Now 2, is it in standard form? Yes. Is there a common factor? No. Is it a special case? Is it a binomial square or a difference of square? No. So 5 is going to now be a times c. My a is 1, my c is negative 12. I need factors of 12, which are 1 and 12, 2 and 6, 3 and 4. My signs are different. I look here, signs when it's negative, that means signs are different, meaning one is positive, one is negative. I look here, and that tells me the bigger of the two is negative. That's my sum of my outside and inside. So bigger is negative, and the signs have to be different. So that gives me negative 11, this gives me negative 4, this gives me negative 1. Which one of those is equal to my middle? This one. So I'm going to use these as my outside and inside. So I am going to turn this into x squared plus 3x minus 4x minus 12 equals 0. And now I'm going to factor by grouping. So I'm going to factor out an x, I get x plus 3. I'm going to factor out a negative 4, I get x plus 3. I know I did it right because these two binomials are the same. I'm going to factor that out, and that leaves me with x minus 4. And now I have a product of two things that equals 0. So I'm going to set each one equal to 0 now, much like just prior to this problems 1 through 9. So now minus 3, x equals negative 3, add 4, x equals 4. Those are my two solutions. And so I'm going to put them in a solution set in numerical order. So it's a lot of work. That actually took maybe more than a minute. So we got to be on our game. So first, set equal to 2, set equal to 2. 1, set equal to 0, yes. Standard form, yes. Common factor, no. Is it a special case? No. So let's do A times C. A is 1, C is 27. Factors of 27 are 1 and 27, 3 and 9, that's it. Signs are the same, both are negative. Negative 12, that's my middle. So I'm going to use negative 3 and negative 9. Negative 3x, negative 9x plus 27 equals 0. Factor by grouping, factor out an x, I get x minus 3. Factor out a negative 9, I get x minus 3. X minus 3, x minus 9. And now I have a product equaling 0. I'm going to set each of those boxes equal to 0 to find out what that x value that would make that box. So when x is 3, it makes that box equal to 0. And when x is equal to 9, it makes the other box. And now we write it in a solution set. That probably took 60 seconds. Set equal to 0, yes. Common factor, no. Sorry. 2 is standard form. Common factor. Special case, no. A times C. 1, negative 32. Factors of 32 are 1 and 32, 2 and 8, 16. 3, no. 4 and 8, 5. That's it. Signs are different. Bigger is negative. That gives me negative 4. That's my middle. So we get 0 equals x squared plus 4x minus 8x minus 32. 0 equals, I'm going to factor in an x. I get x plus 4. I'm going to factor in negative 8. I get x plus 4. X plus 4, x minus 8. Okay, that's good. Now I'm going to set each one equal to 0, each binomial. I'm going to subtract 4. That's one solution. I'm going to add 8. That's the other solution. So when x is negative 4 or x is 8, that will be a solution to this equation. We just solved a crazy equation. Set equal to 0. Standard form. Common factor. Special case. A times C, 1, negative 54. 1 and 54, 2 and 27, 3, yes, 3 and not 2, 1, 18, 6, yes, 6 and 9, that's it. Signs are different, bigger is positive. That's 53, that's 25, that's 15, and that's 3. This is equal to my middle. I'll use these two as my outside and inside. M squared, my outside is negative 6m, my inside is positive 9m, and my last is that. Let's factor by grouping. We'll factor out an m, we'll get m minus 6. We'll factor out a 9, we'll get m minus 6. 0 equals m minus 6, m plus 9. We have a product equaling 0. M minus 6 is 0. M plus 9 equals 0. Add 6. M equals 6 minus 9. M equals negative 9. Those are my solutions. Numerical order, so everybody has the same answer. Set equal to 0. Standard form. Common factor. Oh my. You think I think that's a typo. That's a typo. I never noticed that. This is a typo. This should be X. No way that they're putting Y in there. There isn't. That's a typo. That should be an X. Standard form, common factor. And it's good that we notice, but the book sometimes makes a mistake. Common factor, special case, no. A times C is going to be 1 and 3. Factors are 1 and 3. Signs are the same. Both are negative. We get negative 4. So this is going to be x squared minus x minus 3x plus 3 equals 0. We'll factor out an x. You get x minus 1. Factor out a 3. You get x minus 1. X minus 1. X minus 3 equals 0. And you'll get good where you can already see what the solutions are. Yep. When you do it enough, you can start seeing solutions. You can see where the problem's going because we've done so many and we're familiar with it. So my solutions are 1 and 3. So sorry about that typo. I know that you thought that but set equal to 0. Standard form, common factor, special case, A times C, 1 and negative 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are different, bigger is negative. Negative 23, negative 10, negative 5, negative 2. Negative 10, so we're going to use 2 and negative 12, plus 2x minus 12x minus 24 equals 0. Factor out an x, factor in negative 12. We have x plus 2, x minus 12. X plus 2 equals 0. X minus 12 equals 0. Minus 2. Add 12. So my solution set is negative 2, 12. Let's make that 12. That looks like a European 12. All right, so set equal to 0. We're good. Common standard form. Yes. Common factor. Yes, there's a common factor. We can take out an n and we get n minus 1. So now we've already done, we've turned it into a product. So we set each one equal to 0. That's equal. So my two solutions are 0 and 1. And remember, in the first 9, we saw this very similar problem. So number 1, set equal to 0. It's not equal to 0. So we have to subtract 12y. These are unlike terms, so we get y squared minus 12y equals 0. Standard form, yes. Common factor, yes. We can take out a y. You get y minus 12 equals 0. It's now a product. A product of two things that equals 0. Set each one equal to 0. Y equals 0. That's already isolated. Y minus 12 equals 0. Let's add 12. Y equals 12. So those are my 2's are off today. Okay. Set equal to 0. We're going to minus 2k. Why did I move the k instead of the k squared? Because remember, my coefficient of my first term must be positive. So I need k squared to be a positive. So instead of moving the 6k to the right by subtracting 6k, that would have given me a negative first term. That can't be the case. We can factor out a 2k here, and we get 3k minus 1 equals 0. So, I'm sorry, standard form, yes, common factor. So that's where we are. Product of two things. What value for k makes that equal to 0? And what value for k makes this equal to 0? We're going to divide by 2, divide by 2. That was a big division bar. K equals 0. And add 1. 3k equals 1, divide by 3, k equals 1/3. Numerical order, 0, 1/3. So set equal to 0, it's not equal to 0, so let's minus the 8x from both sides. You get x squared minus 8x plus 16. We're going to put it in standard form, make sure when we move it, our terms are in standard form. Is there a common factor? No. Is it a special case? Maybe. Is it a binomial square? I see three terms. I see the third term is positive. I see that first and third are perfect squares. And now let's check, is the middle equal to 2 times the square root of the first times the square root of the last? So I'm going to bring that down and square it. X times negative 4 is negative 4x. Doubled is negative 8x. So yeah, okay, so what does that mean? What does that mean when we get here? Well, it just means that we have two of these equaling 0. We still have the product of two things that equals 0. Let's set each one equal to 0. We're asking what value for x would make this box equal, so we'll add 4. So when x equals 4, we'll add 4. X equals 4. Now we wouldn't list 4 twice because it's the same number. We just want to know what number or numbers. So it would be silly for us to list 4 twice. We know we just need to write it once. So this is a situation where we have only one solution. Set equal to 0. Let's move these things over. Minus 10 plus 3a, because we want that a squared to be positive. We want the first term always to be positive. We put the 3a in standard form. Common factor, no. Special case, not in this case. So let's do a times c. 1 and negative 10. Factors are 1 and 10. 2 and 5, signs are different. Bigger is positive. That's 9 and 3. That's my middle. We'll use negative 2 and 5. Negative 2, positive 5. Let's factor by grouping. a times a minus 2 plus 5 times a minus 2 equals 0. A minus 2, a plus 5 equals 0. We have two boxes that equal 0, the product of two things. Set them each equal. A minus 2 equals 0. Wow, that's a crazy a. Plus 5 equals 0. Add 2. A equals 2. Subtract 5. A equals negative 5. So my solutions are negative 5 and 2. Let's see how crazy they get. Do they get crazy? Set equal to 0. That's minus 2. Let's put it in standard form. So in standard form, common factor, no. Special case, no. A times C. That's 3 times negative 2 is negative 6. 1 and 6, 2 and 3. Signs are different. Bigger is negative. That's negative 1. So 3x squared plus 2x minus 3x minus 2 equals 0. Factor out an x, we get 3x plus 2. Factor out a negative 1, we get 3x plus 2. 3x plus 2 times the quantity x minus 1. Set each equal to 0. 3x plus 2 equals 0. X minus 1 equals 0. Minus 2. Minus 2 divide by 3. X equals negative 2/3. That's a fun answer. That's actually minus 1. So we'll add 1. X equals 1. My solution set is going to be negative 2/3 and 1. That's already factored, or that's already set equal to 0, excuse me. Standard form, yes. Common factor, no. Special case, no. A times C is 1 times 35, which is 1 and 35, 5 and 7. Signs are the same, both are positive. That's 12. Those are my factors. 0 equals x squared plus 5x plus 7x plus 35. Let's factor out an x. We get x plus 5. Let's factor out a 7. We get x plus 5. They always do this. They go hard, and then they give you this layup problem, which is, it's like, wow, this is an easy one. X plus 5 equals 0. X plus 7 equals 0. Minus 5. X equals negative 5. Minus 7. X equals negative 7. Numerical order is negative 7, negative 5. Keep them in order. All right, okay. That was weird. One easy. Set equal to 0. Minus 14. Y squared plus 5y minus 14 equals 0. Standard form, yes. Common factor, no. Special case, no. A times C. A is 1, C is negative 14. Factors of 14 are 1 and 14, 2 and 7. Signs are different. Bigger is positive. 13 and 5, that's my middle. Y squared plus minus 2y plus 7y minus 14 equals 0. Let's factor out a y. We get y minus 2. Let's factor out a positive 7. We get y minus 2 equals 0. Y minus 2, y plus 7 equals 0. Y minus 2 equals 0. Y plus 7 equals 0. Let's add 2. Y equals 2. Let's subtract 7. Y equals negative 7. Solution set with my solutions are -7 and 2. Set equal to 0, minus 5x minus 36, minus 5x minus 36, x squared minus 5x minus 36 is equal to 0. It's already in standard form. There is no common factor. Is it a special case? Might be. Might be binomial square. So binomial square would be x minus 6, quantity squared. So x times -6 is -6x doubled. Is it equal to -12? No. So not a binomial square. So binomial square, no. That means we move on to a times c. So a times c is going to be 1 and -36, 1 and 36, 2 and 18, 8 and 8, 16, yep, 3 and 12, 4 and 9, 6 and 6. Signs are different. Bigger is negative. -5 is my middle, so this becomes x squared plus 4x minus 9x minus 36 equals 0. Factor out an x, we get x plus 4. Factor out a -9, we get x plus 4 equals 0. X plus 4, x minus 9, x plus 4 equals 0. X minus 9 equals 0. Subtract 4, add 9. My solution, -4 and 9 are my two solutions. Set equal to 0. Did you already recognize it? Can you recognize it when you see it? Have you done so many of these that all of a sudden the red flag, so you're like, oh yes, I know what this is going to go to. Set equal to 0. Standard form. Common factor. Special case. Yes. Two terms. Both perfect squares. Subtraction. We're going to produce conjugates. 2m minus 5. 2m plus 5. Now we have the product of two things. It equals 0. So 2m minus 5 is 0. And 2m plus 5 equals 0. Let's add 5. 2m equals 5. Divide by 2. We get m equals 5 halves. That's one of my solutions. Minus 5. 2m equals -5. Divide by 2. m equals -5 halves. So there's a couple ways that you can write this solution. One way is to write the two solutions, -5 halves and +5 halves. In high school, you're going to see this sign, plus or minus. And that's a nice way of writing the plus and the minus. That's two solutions. It's one way of showing solutions with a positive and negative value. Okay, so you learned something new today. Let's set equal to 0. Minus 9r minus 9r. R squared minus 9r plus 8 equals 0. It's already in standard form. There is not a common factor. It is not a special case. So we do our a times c, which is 1 and 8, which is 8, which is 1 and 8. Signs are the same. Both are negative. That's my middle. R squared minus r minus 8r plus 8 equals 0. Factor out an r, r minus 1. Factor out a -8, r minus 1. We get r minus 1, r minus 8. Set them equal to 0. Add 1, r equals 1. Add 8, r equals 8. 1 and 8. We're almost there. A couple more. Okay, a whole lot more. Set equal to 0. Let's subtract 2. 6n squared minus n minus 2 equals 0. This is a good one. Standard form, yes. Common factor, no. Special case, no. A times c. And this is fun just because we have an a value, which makes negative 12, 1 and 12, 2 and 6, 3 and 4. Signs are different. Bigger is negative. Negative 1. So those are my two. 6n squared plus 3n minus 4n minus 2 equals 0. Factor a 3n, that's cool. 2n plus 1, factor out a negative, negative 2, which is 2n plus 1. So we have 2n plus 1 times the quantity 3n minus 2 equals 0. Set them each equal to 0. 2n plus 1 equals 0. 3n minus 2 equals 0. Minus 1. 2n equals negative 1. Divide by 2. N equals negative 1/2. Add 2. 3n equals 2. Divide by 3. N equals 2/3. My solution set, negative 1/2. 2/3. Those are the only two values that would work. Set equal to 0. On problem number 28, baby. Negative 4x. 3x squared minus 4x plus 1. We got to be getting good at this, yeah? Standard form. Common factor. Special case. A times c. 3 and 1. Which is 3, which is 1 and 3. Signs are the same. Both are negative. Negative 4. 3x squared minus x minus 3x plus 1. Ooh, that's a good one. X gives me 3x minus 1. Negative 1. 3x minus 1. That was a little tricky. A lot of students struggle with factoring out that negative 1. So this is a good tester. Do you recognize that one? And now it's home stretch. Now this is the easy part. All you're doing is a one-step or a two-step problem. Solve for the variable. We get x equals 1/3. Add 1. X equals 1. 1/3 and 1 are my two solutions. All right, a couple more. Set equal to 0. Let's hopefully they get challenging. Minus 6a. We get 3a squared minus 6a equals 0. Standard form, yes. Common factor, yes. We have 3a, and that gives us a minus 6. Nope, a minus 2. Would have made a mistake. I'm rushing. Set them each equal to 0. 3a equals 0. A minus 2 equals 0. Divide by 3, divide by 3. Again, on an assessment, you would take the time to check your answers. This is a speed explanation. We're trying to get through these worksheets. So I am not checking each of these solutions, which I probably should. Oh, this is good. We see this. Oh, no, no, no. Well, this is going to be a big one, that's for sure. Set equal to 0. Minus 80. I thought there was going to be a common factor, but no number goes into 3, 14, and 80. Standard form, common factor, no, as we just alluded to. Special case, no. A times c. Hi-ya. That's a big negative 240. 1, 240, 2, 120, 3, 80, 4, 60, 5, yes, 5 goes into that. 5 goes into that. 48 times 6, yes. 6 and 40, 7, I don't think so. 8, yes. 8 and 30, 9, no. 10, yes. 10 and 24, 11, no. 12, yes. 12 and 20, 13, no. 14, no. 15, no. 16, 16, yes. 16, oh, 15 and 16, sorry, 15 and 16. All right, now my signs are different. Bigger is negative. Bigger is negative. Look at all of these factor pairs. Whew. That's negative 239. This is negative 118. This is negative 77. This is negative 56. This is negative 43. This is negative 34. This is negative 22. This is negative 14. This is negative 8. This is negative 1. Which one's equal? Negative 14. Those are my factor pairs, 10 and negative 24. 10 and negative 24. Let's factor out just a p. We get 3p plus 10. Let's factor out negative 8, which gives us 3p plus 10. We get 3p plus 10. P minus 8 equals 0. All right, that was kind of fun. It was a little different, a little bit just in our factor pairs, but not harder necessarily with all the little tricks that they can do. Minus 10. 3p equals negative 10 divided by 3. We get p equals negative 10 thirds plus 8, p equals 8. My two solutions, negative 10 thirds, comma 8. There you go. 1, 2, 3, 3 more. I'm going to move it over because I want my x squared to be positive. 2x squared minus x minus 10 equals 0. That is me setting it equal to 0. It is in standard form. There is no common factor. It is not a special case, so let's do a times c. 2 and negative 10 is negative 20. 1 and 20, 2 and 10, 4 and 5. Signs are different. Bigger is negative. Negative 1. 2x squared plus 4x minus 5x minus 10 equals 0. Let's factor out a 2x. We get x plus 2. Let's factor out a negative 5. We get x plus 2. That produces the two binomials of x plus 2, 2x minus 5. Set them each equal to 0. X plus 2 equals 0. 2x minus 5 equals 0. Minus 2. X equals negative 2. Add 5. 2x equals 5 divided by 2. X equals 5 halves. My solutions, negative 2 and 5 halves. I'm not going to turn that to a mixed number. It just doesn't really behoove me. Set equal to 0. Let's add 10 to both sides. 3p squared plus 17p plus 10 equals 0. My hand's getting tired. Standard form, common factor, special case, a times c. I got 2 more. Come on. My neck's getting tight. 3 times 10 is 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Signs are the same. Both are positive. Here's my 17. 3p squared plus 2p plus 15p plus 10 equals 0. Let's factor out a p. We get 3p plus 2. My handwriting is getting tired. Factor out a 5. 3p plus 2 equals 0. Stay with it. Finish strong, Mr. McCausland. Don't give up. You can do it. Equals 0. P plus 5 equals 0. Minus 2. 3p equals negative 2 divided by 3. P equals negative 2/3 minus 5. P equals negative 5. Negative 5 is smaller than negative 2/3, so that comes first. How much time are we doing? I mean, I got 33 problems. Let's hope that I did each one of these faster than, set equals 0, sorry. Faster than a minute. 3x squared minus 4x plus 1 equals 0. 2 is standard form. 3 is common factor. 4 is special case. 5 is A times C. 3 and 1 is 3. 1 and 3, signs are the same. Both are negative. That's working. 3x squared, I feel like I've done this one before. Well, with how many we do, it's not surprising that it would feel like that. Minus 3, oh, not minus 3, minus 1. Almost made a mistake on the last one. Come on, focus, stay with it. Have the same enthusiasm you had when you started this video about an hour ago. 3x minus 1 equals 0. X minus 1 equals 0. Add 1. 3x equals 1. Divide by 3. X equals 1/3. Handwriting breaking down. Shoulder weakening. Woo! Oh, that was bad. All right. I will at least finish with that nice doozy. That's solving. Now these expressions have become equations. And there goes the pen into its bucket. Here we go. Nice job. If you made it this far, congrats. As always, I feel like, what is it, Tony Robbins? P90X workout. Have a good one. Thanks for coming.